Hello,
Good
everyone.
evening. How are you?
Good
Oh, there we
evening.
go. John, where are you?
Somebody's got an extra speaker on.
Probably me.
No, it was me. I plead ignorance,
Yeah.
but it's off.
All right.
Oh, there's John. Hey, so we're all here.
Hey,
Hey, let me introduce Gerald McKeegan and Rick Taft and John Curry. I'm Rich Ozer. And it's been a couple of weeks since we had a virtual telescope, and it feels like an eternity. I've missed you all.
Yeah, we
So
had to remember how to do this.
I know it took me a lot longer tonight to get it all set up. I
Yeah.
couldn't remember how. So thank you all for attending. I want to remind everyone that the Chabot Space and Science Center is about to reopen. Notice I've changed the opening line here. No longer saying, I want to remind everyone that the Chabot Space and Science Center is closed. I want to say that we're about to reopen, and that is going to be happening on the weekend of the 12th of November. So, hopefully we have some good weather. You can come up on Friday and Saturday night and look through the telescopes again. The Telescope Makers Workshop will be reopening on the 19th. And this is our penultimate virtual telescope program for Saturday night. We'll have one more next Saturday, and then we are going to be deciding which night of the month that we'll continue to have this program, probably once a month for the foreseeable future. So we're not going completely away. So, pretty much just good news and good news, and appreciate everyone's participation. I want to encourage everyone to make a donation to the Chabot Space and Science Center. If you're on Facebook, there's a little donate button somewhere on your screen, probably on the bottom. In Gerald's case, it's right in the middle. And I think if you have a Mac, it's on the top.
That's where the start button is now.
If you have an
right in the
iPad,
middle.
it's on the lower right. It's on the bottom right-hand side.
it's usually
And,
wherever it gets in the way.
Yeah, that's right. And it follows your mouse around. That's a new feature. And you can also visit chabotspace.org and learn how to become a member of the Chabot Space and Science Center or make a donation from there. And I also want to thank Fremont Bank for its support of this program and others, and ongoing for the last couple of years. So that's it for all the commercials. And we have 100% humidity tonight. That means we're not looking through telescopes. We will talk about telescopes and we will talk about astronomy. We've got some good stories. Really, Gerald, the first story tonight that I think we should talk about is the Aurora.
Yeah, well, yeah, the Aurora and the coronal mass ejection and all that good stuff.
Yep.
Yeah.
Yep.
So a couple of days ago, on the 28th, the sun burped, and the sun had
What's the technical term?
yeah, the sun burped. so the sun had what's called a coronal mass ejection, which is not unusual. The sun has these periodically. This is where it's very much like a burp. It just spews gas out into space, and ionized particles, and they go streaming out into space. Most of the time, those particles won't go streaming off in some other direction. But once in a while, we get one that's aimed right at the Earth. And the one that happened on the 28th was aimed right at the Earth. So there has been this massive cloud of ionized particles, ionized gas, blowing toward us at a pretty high rate of speed, and it is just now passing over the Earth. And it's events like this that produce particularly active auroras. So if you're up in the northern part of the country, Richard, I think you saw somebody from Idaho or.
Yeah, I've seen one report that it got as far south as Idaho. I don't know if anybody else has reports about where the aurora is visible tonight. If you happen to see it or you know somebody who has seen it, go ahead and post it in the chat.
Yeah, yeah. So you should be able to see, if you're far enough north, you should be able to see Aurora. You will see it a lot farther south than what you would normally see. And that's because all these charged particles are being redirected by the Earth's magnetic field towards the poles, and they wash over the Earth, but the magnetic field pulls them around and then brings them down towards the north magnetic pole and the south magnetic pole. And as those charged particles enter our atmosphere, we get the aurora. Um, and so pretty good light show and fairly far south. You can still see it right now. So what's happening is the sun is working its way back into its active period. The sun has an 11-year cycle of high activity and then low activity and then high activity. The high activity periods are distinguished by lots of sunspots on the sun. A couple of years ago, we weren't seeing any sunspots. Now we're seeing a few. And in this case, there was one that appeared, oh gosh, I'd say about not quite a week ago. And then on the 28th, it caused this coronal mass ejection, which sent all of these ionized particles out into space. And it's going to cause the auroras. There's potential for disruption of communication and so on and so forth. And this is not unusual. It happens periodically. And we're going to see more and more sunspot activity as the sun ramps up towards solar maximum, when we have the maximum number of sunspots. I think that's going to be in 2023. So we are ramping our way up, and we're already getting some pretty good activity. So
the same phenomenon that can disrupt communication, basically having high energy streaming through the atmosphere, also sometimes creates large power outages.
Right.
So I don't know if you remember that that outage on the East Coast where the entire eastern seaboard went dark for one night. And I forget what year that was, but it was a massive CME event.
Right. Right.
Yeah,
so I've got some graphics here to show you, if you don't mind. Real fast here. Let's see. There you go. So this is a graphic put together by the Space Weather Prediction Center, which is part of the National Oceanographic and Atmospheric Administration. And what this shows, it starts back on the 28th, and it shows the propagation of the coronal mass ejection as it moves outward. This little dot right here, this is the sun. This dot right here is the Earth. This is the two stereo spacecraft right here. And this shows the density of the hot plasma, the ionized gas that's blowing out. And you can see that it's right about now is when it's passing over the Earth. This shows a similar thing, but this shows the velocity of the gas. And at its maximum, the velocity is close to 800 kilometers per second. Wow. So it is really moving. And that's compared to a more typical speed for the solar wind of a couple of 100 kilometers per second or less. So this has really ramped up the velocity of the solar wind, and you've got this dense cloud of hot plasma, ionized gas that's passing over the Earth right now, producing all these really cool effects. And let's see if I can find my other graphic. That's not the one I wanted. That comes later. There we go.
Yeah.
So this gives you an idea what the aurora is going to be like. This was actually for last night, and it's going to be even more pronounced tonight. So the aurora is all this ionized material coming down towards the north magnetic pole, and glowing as it enters the atmosphere. So anyway, pretty cool stuff. If you happen to be listening in from way far north, like up in Idaho or Maine or someplace like that, you ought to be seeing a really good aurora right now.
Hey,
I want to
tell you, they were forecasting the aurora in Seattle. I was just there my luck, I just left last night, got back in
Oh,
early this
man.
morning, and they're predicting the Aurora in Seattle. So if
Yeah,
there's anyone
yeah.
that far south, you're in for a really neat display.
Yeah,
Let me show a photograph that one of our EAS members took of the coronal mass ejection. This was taken through a small telescope called a lunt, and it's a 100 millimeter aperture. It's a specially designed telescope for looking at the surface of the sun and seeing solar features. You don't look at the sun through a standard telescope, or else you will be a one-eyed astronomer.
yeah. Right, right.
Yeah, this is a special solar telescope, and it was taken by Gert Gottschalk. And this bright area here is the coronal mass ejection. He was taking video when it finally burst.
Yeah.
And I thought this is a really nice photograph taken from Fremont, California.
Wow.
So you can't see it very well in this image because of the all of the material being thrown up, but there's actually a couple of sunspots. Sunspots typically occur in pairs.
Yeah. Yep, there they are.
Sunspots typically occur in pairs, and they represent the north and south magnetic poles of a localized magnetic field within the sun's atmosphere. In these 11-year cycles, what's happening is the sun is generating a lot of magnetic activity in the convection part of the sun, which is just below the surface that we see. And those magnetic fields are kind of random for a while, but then they start lining up. And because of the differential rotation of the sun, and by that I mean that the sun's equator rotates faster than its temperate zones. So as you get farther away from the equator on the sun, the rate of rotation actually is slower. That causes the magnetic field lines to kind of get stretched out in a loop. And this goes on and it gets worse and worse and worse. And pretty soon you've got these long looped magnetic field lines, and they start to break. And as they do, they form these local sunspot areas, and you get material flowing from the North Pole to the South Pole of this localized magnetic field. But that's a very active region, and occasionally what happens is you get this explosive release of material, hot gases, plasma from the sun, and you get a coronal mass ejection. It's one of the more dynamic things that goes on the sun's surface.
Hey, Rick, don't feel too bad. I see a comment from Lynn, who's just east of Seattle, and she hasn't seen any aurora tonight, even though she's got clear skies.
Well,
so maybe you didn't miss anything after all.
Well, I hope not, but keep watching. And if you see that, be sure to let us know in the chatter for the next session here.
Yeah, really good.
Gerald, there's just something else I'll mention about the sunspots. Another hobby I'm involved with is ham radio, amateur radio. And amateur radio operators have been waiting for years, literally, for the start of the new sunspot cycle. And I think we're in sunspot cycle 25.
25, yeah.
It's really good for them, yeah.
It is on the uptick. And what that means is that radio operators around the world will be able to more easily talk to one another using skip transmission, where the signal bounces off ionized layers in the upper atmosphere, in the ionosphere. And so at any rate, if you're a ham radio operator, you should be smiling right now, because things are going to be getting a lot better.
All right. So that's what I have. Richard, I think you said you had something else you wanted to chat about tonight.
Well, I think we ought to work our way out from the sun.
Okay.
And so I'm gonna put it back on you, because you had a story about Jupiter.
Oh yeah. Okay.
which you teased us with in the middle
Yeah.
of the
Right,
assignment.
accidentally.
Yeah, I accidentally. Yeah, yeah. So let me accidentally go back to my and accidentally find my way to it.
We had the preview. Now we want to go.
Yeah,
Yeah.
that was
What it
that.
is, you were-
That was the teaser. Here we go. All right. So the Great Red Spot on Jupiter. There's a spacecraft orbiting around Jupiter right now. It's called Juno. Juno is in a highly elongated orbit that takes it out pretty far away from Jupiter and then very close in to Jupiter. Takes 53 days to do one orbit. And some researchers have been looking at the Great Red Spot when Juno was in close to the surface of Jupiter. By the way, when it's in close, it's moving really fast at about 130 miles per hour, 130,000 miles per hour. So that's really pretty fast. That's among the fastest spacecraft that we've had out there. Anyway, so they made several passes over the Great Red Spot, and what they were trying to do is get a sense for how deep it is. So we see the Great Red Spot on the upper part of Jupiter's atmosphere, the cloud tops, if you will. We know it's a big giant cyclone in the atmosphere of Jupiter, and it is very large. It's actually larger than the Earth. The Earth is about 12,000, a little over 12,000 kilometers, so maybe this big. I'm assuming you can see my cursor. And then the Great Red Spot is about 16,000 kilometers across. So it's very large. But the question was, how deep does it go into Jupiter's atmosphere? And this new data that just came out here within the last few days says that it goes about 500 kilometers deep. So you think about that, it's about 16,000 kilometers wide, but only 5 kilometers deep. So it's basically a pancake laying on top of Jupiter's atmosphere. So it actually doesn't go very deep, but it does go deeper than most astronomers thought it would go. So
I think it's more of a biscuit.
okay.
I like the pancake idea myself.
Yeah. To me, the pancake is more indicative of the ratio between the width of it and the depth of it. Yeah. But we still don't know what causes it. Why is it still there? It's been there for a couple of 100 years at least, and we're still not quite sure what causes it. Why does it continue to go? That's something that hopefully with a few more passes by Juno, we might get a better sense of what's going on there. The fact that it does go down 500 kilometers, though, means it gets down into the part of the atmosphere where there's a lot of water. The atmosphere is mostly hydrogen and helium, some methane, and a few other gases. But as you get a little deeper, there's a kind of a watery layer. It's still gaseous and still mostly hydrogen, but there's a lot of water there. And the fact that it's 500 kilometers deep means it gets down to the water layer in the atmosphere. So what that means, I don't know. But it is pretty interesting, and it is a very, very new data that just came out within the last couple of days. All right.
Gerald, a couple of people have asked what makes the color.
That's material churned up from underneath. So you get all these different gases. Again, it's mostly hydrogen and helium, but you get some organic compounds, carbon compounds deeper in the atmosphere, and that gets churned up by this cyclone, and that's what gives it the color.
And there's another factor there too. Since the material is getting churned up, it's bringing to the surface warmer gases as well, because the temperature in Jupiter gets increasingly warm as you go further towards the center. And so you've got warm gases interacting with the cold gases in the upper atmosphere, and that might be causing chemical reactions that otherwise would not occur.
Which is what accounts for a lot of these organic compounds. One of the interesting things about Jupiter is that internally it actually generates more heat than it receives from the sun. So, on the Earth, we get a lot of heat energy. If you add up all the energy from the sun that's striking the Earth, it's actually more heat energy coming in than is being produced internally within the Earth. But
sometimes
on Jupiter,
too much.
Yeah. But on Jupiter, up at the cloud tops, it's very cold. But deep down, it's quite warm because of the strong gravity. You've got all this compression going on, and that produces a lot of heat. And so Jupiter generates more heat than it receives. So one of the interesting properties, I believe it's the only planet in the solar system that does that. All right, how are we doing on questions here? What effect will it, there's a good question. Someone asked about how the coronal mass ejection will affect the space station. It will affect the space station. It's going to affect their communications ability. It's going to increase the amount of radiation that they're exposed to. They actually have sections in the space station where the astronauts can go shelter if they need to. If the amount of radiation it gets too high a level, they will actually go and shelter in these shielded sections of the space station and wait it out. It won't last very long. A couple of hours or so is all it lasts. So they do have a way of shielding themselves against that if that.
What material did they use for shielding?
I'm not sure. I think it's a water shell.
Water.
Yeah,
water, right?
yeah.
I mean, it's a lot easier to move water up there than it is to move lead.
Yes.
Yeah, for sure.
It's got to be water. Interesting.
Yeah, that's a good question. We should look that up. Maybe talk about it next time.
Tim says that Jupiter, Uranus, Neptune, and maybe Saturn all emit more energy than
really. Okay.
Neptune by about a factor of 2. That's wild.
Wow.
Planets.
All right.
So
okay, we got some
farther out.
Yeah.
Farther out. So I'm going to share my screen here. We still have several magnificent instruments in space, and the one we haven't heard much about in recent years, unless you've been, a principal investigator on one of the projects, has been the Chandra Space Telescope. And unlike the Hubble Space Telescope, it doesn't look at visible light. It looks at X-rays. X-rays are a form of light, just a very high energy form of light, not visible to our eye, but it is light nonetheless. It ruins film, right? And the Chandra Space Telescope is designed to look at the most high energy events that take place in the universe and study them. And they had an interesting discovery last week, or in the last couple of weeks. They were studying M51, which is a spiral galaxy in Ursa Major, right? And it's 28 million light years away. It's very far away. And the reason it was studying M51 is there's a particular star grouping that is a neutron star orbiting a black hole. Now that sounds like a truly nasty place. Interesting to study though. And the reason you got Chandra pointing at it is that black hole at the best of times is emanating all kinds of X-ray energy. And it's one of the ways you can study a black hole is to look at the X-rays that are being generated at the event horizon.
It's how they
Or-
first discovered
That's
real
right.
black holes.
That's right. It's Cygnus X1 was
Uh-huh.
the black hole in the constellation Cygnus, and it was discovered that way. But if you got a neutron star orbiting a black hole, then you've really got a lot of energetic activity going on in one place. And what they noticed was that in a very regular pattern, the amount of X-ray energy was dropping off and rising, dropping off and rising. And what they realized was that it was following the pattern of a planet orbiting a star. And they believe that they detected the first extrasolar planet in another galaxy about the size of Saturn orbiting this binary system of neutron star and black hole, which is a crazy thing to think.
Oh, yeah, really.
But, I mean, this planet has gotten the heck beaten out of it because, I mean, for it to be orbiting a black hole means that, you know, or even a neutron star means that whatever star it, you know, was originally formed from had already gone through its end of life stages and probably supernova. And somehow it managed to survive that. and now is in a things went from better to worse, and now it's orbiting a neutron star and black hole. But anyway, the data is very suggestive of the first, I guess would be extragalactic planetary discovery. And we'll see. They need to gather more data because maybe it could be something else, right?
You say that was in M51?
M51. Do you have a picture of M51?
I do.
We have
Yeah,
several of them, I think.
Why don't you show
I
a
have
picture of
one. I have
M51?
one right here. How's
All right.
that?
All right. Yeah, we
Yeah.
took that right here.
Yeah, we took that right here with Nellie.
Yeah.
So this is
So-
M51. You don't happen to know whereabouts?
Yeah, it was like right in this little area right around here, I believe, was where they were pointing.
Well, you're pointing, but I can't see where you.
Oh, got it. Oh, you're right. Ha!
So
Pointer. Move up, 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 to the right, to the right, to the right. Out there.
right in here.
Yeah, right around that
Okay.
area.
All right. All right.
That's don't we have let me check real quick. I think
Yeah,
we have a
we have
video
a
of
supernova.
supernova, yeah,
Yep.
from
We do.
M51.
We
Yeah.
do. Yep.
Oh, I didn't know that.
Let me see if I have that handy here. I can.
Well, maybe it's that neutron star collided with the
Maybe.
You know, that's a good question because I think that is actually where it is.
It's right in that area. I remember.
Yeah, hang
Well,
on
it's a
here. I got
very
it.
energetic part of M51.
Yeah.
Stand by here. I think I've got yes. No, that's not it.
I have it if you want.
Yeah, go for it, John. Go ahead and share.
Let me bring this up a little bit and then share here.
Oh yeah, here we go. You see it?
I'm waiting for John to share.
Yeah,
Oh.
hang on
I-
just
I-
a second here.
I thought I was sharing.
Yeah, but you're about to be kicked
You are
off.
sharing.
Yeah. Okay. So this is the image I think
I'm
that
tr- yeah, I can't
Oh, you can't? Hold on. No,
seem to
that's-
share because of.
All right, hold
Not
on.
sure
let me-
what.
Maybe Gerald needs to stop sharing.
Yeah, Gerald, go ahead and stop your share. Yeah, now John, give it a shot.
Okay, let's see here.
I had it set that any of us could bump anyone else off, but it didn't work.
Yeah, can you see that?
no.
Not yet.
Why not?
Says
Oh,
you're
okay.
sharing your screen, but no image.
Oh, well.
It's working on it. Wait a minute.
It's probably the same image I was just showing.
Here. I'm sure it is. Zoom just quit on me. Oh well.
Oh, well.
Well, let me try.
Okay, are you able to grab the share?
Yeah,
Yeah.
yeah, go ahead.
All right. I think we got it there. You see it?
I don't.
And
Really, what's going on here?
It still shows
Hold
John
on.
is sharing.
Let me see if I
Black screen.
could, let me see if I could get this back. And now I'll stop sharing. And now it should be,
Yeah, it's still showing John.
there we go.
Okay.
Now-
Try,
all right,
Try one more time.
we're out of share jail.
Yeah. Can you see it now?
Yeah,
Yep, that's
Yeah.
the same one. Yep.
Okay. So this is where that supernova was. This was
That's,
a few
yeah, that's
years
on
ago.
the other side. Yeah.
Yeah. So yours was over here.
Oh,
Yeah.
right.
Yeah,
Yeah.
yeah.
This is upside down from the other image. Yeah.
All right. Well, that was fun.
Yeah. Anyway, that was my story. That was the most exciting thing I read this week about deep sky astronomy. But speaking of deep sky astronomy, Rick has brought along some fine photographs, and hopefully he'll be able to share.
Well, let's see what happens here. Whoop.
Yeah.
Yep, there you go.
All right. Now
I see the moon.
Okay, now we're going to talk about deep sky astronomy, but first we want to bring it a little closer.
Okay.
So you guys may remember a couple of weeks ago, it was the International Observe the Moon Night. We were looking at the moon and someone said, "What's your favorite crater?" And of course I replied, Clavius.
Hey, there it is.
And we got into this big discussion about the Clavius base and Tycho and the monolith. And at any rate, it was a wonderful, wonderful evening discussion. If you missed it, you can go back and see one of the reruns. However, a good friend of ours, Dan van der Zanden, was in his backyard that night, and he was doing some imaging with his telescope. And he heard the discussion, and he took a picture of Clavius for me and sent it in. And I thought I would give him a shout out and share it. And if you can see the mouse here, this is Clavius at the bottom of the image here. And I just thought that was pretty cool that Dan would take the time to take that image and send it in. Now, let me go back here. I want to stop share for a second. So Dan was in his backyard, and he is quite an accomplished astrophotographer. And this is what he was actually working on. And now, are we seeing this?
Yes.
All right. This is what Dan was working on. So we've now gone out in deeper space, and we're looking at about a 50-degree slice of the sky. This is a photo mosaic that was created over 165.
Oops.
Normally, when we use we just lost the image. I'm seeing myself.
Yeah.
Your
Yeah.
voice cut off too, right
Did
at
it really?
165. 165 what?
Okay, so let me
Probably hours.
go back to Zoom. So let me go back to share. Whoop, that's the wrong one. Wait a minute, let's go back here. It says screen sharing has stopped. Let me try this again. So I'm going to go to share screen. And here's Dan's image. Now, are we back?
Yeah, we got it.
Okay.
Yep.
All right, so I'm going to keep my fingers crossed. This is the perils of doing anything on live Zoom, But at any rate, this image was taken over many weeks from a backyard in I think it's in Danville area. And there's over 165 hours of imaging represented in this photo mosaic. And if you look at the mosaic, it's actually composed of about 7 discrete panels that were all assembled using special software, using PixInsight, if there are any astrophotographers out there. The image itself was created using a 70 millimeter telephoto lens, a lens that you might have on your DSLR camera. So it's actually looking at a fairly large picture of the sky. And over many successive nights, this image was produced. Now, the image itself is what is called false color. It uses what astronomers or astrophotographers refer to as the Hubble palette. So the image is actually a combination of images that were taken in the light, in the wavelength of hydrogen alpha, in oxygen 3, and in sulfur 2. And all of that was composited to create this image. And the image itself extends from the Tulip Nebula in Cygnus at the lower right corner of the image to the Bubble Nebula in Cassiopeia at the upper left corner. And again, it spans roughly a 50-degree arc of the sky.
Jeez.
It's absolutely amazing. And I'm going to try zooming in. And this is the North American Nebula, and I think the Pelican Nebula, but you can see the detail. And I think this will show up on Zoom.
Yeah, it does, and it looks very good.
This is it's an ultra high resolution image, and I think what Dan has done is nothing short of amazing from a light polluted backyard in the Bay Area. So
yeah, really.
That's kudos to Dan van der Zanden for that image.
Hey, Sabina mentions that maybe our cutoffs and things are due to the CME that we just had. So,
well, you know what?
That is
the most intelligent explanation.
Right. It's a good excuse. At least.
It's a lot better than blaming it on Zoom.
Right.
Yeah. Hey, another question came up on YouTube. I thought was a really good question. Going back to our conversation about the black hole and the neutron star. And the question is, why does a black hole shoot out X-rays if it has such great gravity? And the answer has to do with it has to do with what's called the accretion disk. So you got the black hole, which is actually a point in space surrounded by a region, what we call the black hole. The black hole itself is not an object. It's a region that surrounds what's called a singularity. Anything that happens closer to the singularity than the perimeter of the black hole, we can't see. But around the black hole is an accretion disk. It's material, remnants of stars and planets and, Tesla roadsters and whatever else might be out there that are being pulled into the black hole. And as the black hole pulls it in, it goes into a flat sort of torus or disk around the black hole as this stuff is spiraling in. At the same time, it's heating up, and it gets hotter and hotter and hotter as it gets closer in toward the black hole. It gets hot enough to where the energy is so great, it emits energy in the X-ray part of the spectrum instead of just in the light part of the spectrum. And that's common of anything that you heat up hot enough, it will emit X-rays. If you get it, tens of thousands of degrees, then it will get hot enough to emit X-rays. So what's happening is the black hole is pulling this material into the accretion disk where it heats up and eventually gets hot enough to emit X-rays. So that's why the black hole is emitting X-rays. And because that is happening outside of what we call the event horizon, which is the boundary of the black hole part of it, we can see it, and we can see those X-rays.
Good explanation. Thank you. So Stephen asks a really interesting question. I'm going to give it a shot to answer this. Correct me if I'm wrong, Gerald. So why is our solar system on an angle in relation to the larger galactic plane? I think that's a really great question. So the galactic plane really doesn't have any geometric effect on the accretion of material when a star is forming. So if you have a hydrogen cloud that condenses and creates a star, and that's accretion has a certain amount of spin to it, that spin is going to determine the plane of the resulting solar system. And the angle of that solar system is going to be random. And it's going to be random because it's going to be a local effect of the accretion of the hydrogen gas that formed the host star. And the solar system that is formed around that star is going to be on the same plane as the equatorial plane of the spinning star, which is going to be oriented randomly with respect to the galactic plane and randomly with respect to all the stars surrounding it. So sometimes we see other stars and other star systems that are in the same plane as our own solar system. And sometimes we see them turned, as far as 90 degrees from that plane.
Yeah,
And it's
they can
really
be
all over the map.
right. They can be in any direction, right?
Doesn't the rotation of the galaxy have some influence on that, though?
No.
It seems to me that there would be, at least some stars affected by the rotation of the galaxy.
I think it's a great question. And I think you'd have to look at the observed planes of many, many solar systems to see if there's a bias toward the galactic plane.
Yeah.
And I don't know of any studies that have done that, but it's a great question.
Well, we know they are random because that affects how many exoplanets we could see. If all of the solar systems were coplanar, we would have discovered many more exoplanets than we have. But because the plane of the orbits can be oriented in any which direction, the only ones that we can discover using the transit method or even the Doppler shift method are the ones that are more or less oriented parallel to our plane or along our line of sight, actually.
Yeah.
They are truly random, and there is no preferential direction for the plane of the orbits of planets around stars.
Great questions.
Yeah.
See. Travel.
Stephen says, anyone care to comment about the several recent near-Earth asteroids that pass close to Earth? Gerald, that would be you.
Gerald, yeah.
Yeah. I think we've had 18 or 19 of them this month alone passing closer to the Earth than the Moon. This is actually not unusual. It's unusual that there were that many, but only because we're getting better at detecting them. So it's probably very common for us to have 2 or 3 of them get that close every week. But because we have so many people now looking for them and the equipment is more sophisticated, now that we have both Pan-STARRS 1 and Pan-STARRS 2 and Atlas, and all those survey telescopes are now operating, we're finding more of them. So, yeah, if there's a website that JPL has where you can go and look and see all the upcoming close approaches, and if you look at that, you'll see that there are a lot more than what it would have shown, say, 5 years ago. But it's only because we are getting better at finding the near-Earth asteroids, not because we're suddenly getting a swarm of them or anything like that. So not to worry.
Not too much, anyway.
Not too much, yeah. Now, along those lines, I should comment, in a couple of weeks here, actually 3 weeks, a little over 3 weeks, we're going to have the launch of the DART mission, which is a mission to go up and test one of the technologies for deflecting an asteroid, should we detect one with our name on it. So that's called a DART mission. It's a double asteroid redirection test. And this is a spacecraft that's going to go out to a binary near-Earth asteroid. It's an asteroid called Didymos. It's a binary system, so it's got a large asteroid. It's about, I think, around 800 meters in diameter, and it's orbited by a smaller asteroid. It's about 160 meters in diameter. And DART is going to go out there and it's going to ram into the smaller one. And it's going to do that at the time next fall when the asteroid is especially close to the Earth. So we'll be able to observe it with Earth-based telescopes and Earth-based radar and actually measure the effect of that impact on the motion of the smaller asteroid. And the intent is to create a very small but measurable change in the asteroid's velocity. And if that's successful, then that will demonstrate what's called the kinetic impactor method of changing the orbit of an asteroid.
Is that smaller asteroid bright enough to be seen with Nellie?
It should be, yeah. Yeah,
so maybe you can participate in the data.
I got to wait till September of next
Right.
year, though. So,
Well, we got plenty of time
Put
to
it
get
on
ready
your
for it.
calendar.
yeah. so anyway,
We'll be writing it down. Right? We got to carry this live.
yeah.
Right.
So the DART mission will launch on what for us here on the West Coast is the evening of the 23rd of November. If you're on the East Coast, I think it's a little bit after midnight on the 24th. And it's launching from Vandenberg Air Force Base here in California. So
That'll be fun.
that'll be something to look forward to here. And, we'll talk about that some more as we get closer to the launch date.
Sounds like a field trip.
Yeah.
Yeah, I think so.
Yeah, go down there and watch the launch.
Yep.
Nice nighttime launch. So we'll probably get all kinds of phone calls after that because people see the streak across the sky and say, So any other questions?
Yeah, Stephen asks, anyone care to comment about the problem with the Lucy probe going to the Trojan asteroids?
Yeah, they got
Jupiter?
solar panels. Lucy probe has these solar panels that are supposed to extend out. It's where it gets its electrical power. These are solar panels similar to the ones that you have on the roof of your house to generate electricity. And the way it's supposed to work, these things are kind of fan folded together during launch. And then once it gets up into space and on its way, they open up. Well, one of them has not fully opened. So there's a possibility that there's some cabling that's gotten hung up or something like that. So the intent is to refold it and then redeploy it again. But they want to do a whole bunch of testing and make sure they figure out exactly how to do that so they don't make matters even worse.
You can easily make it worse because it's all wires and pulleys.
Right.
And if one of the wires has come off the pulley, if you tighten it down, you can end up snapping something. So it's
or tying a knot in it,
or
making it
tying a
really
knot.
jammed.
Yeah, it's very risky.
Yeah. Now, other than that, the spacecraft is working fine. It's just that this one solar panel has not fully deployed. I think there's 3 of them that extend out. There's 3 solar panel wings, they call them, and it's only one of them that's partially deployed. So they're getting electrical power, but they want to get more because when they get out to Jupiter, the amount of solar radiation that you get out at Jupiter is a lot less than, when you're this close to as close as the sun is. I mean, as close as the Earth is.
Well,
that's a great segue for the another question right after that.
Yes.
Holly asks, why is Jupiter's moon Europa frozen?
Because it's cold out there.
Too far away.
Yeah.
It's cold.
It's cold.
So the fact that the solar panel on the spacecraft has not fully opened won't stop it from its scientific mission.
Right.
It may mean that it won't have quite as many hours, maybe, but for the most part, it will still be able to do what it was supposed to do.
And it may also not have enough power to send high resolution images at high speed. It may have to do a low speed transmission.
Low speed, yeah. I've been there before.
Yeah.
It was several spacecraft.
Yep.
So Tim pointed out, oh, and the James Webb Space Telescope has how many things that have to open up? And the last count was
Good point.
I think 300.
Yeah.
There are 300 steps to the unfolding of the James Webb.
I'll tell you, man,
telescope.
there are going to be some people just gnawing the fingers down to
Oh
nubs.
my God.
This thing is not going. So let's see, the mirror segments all have to unfold. The heat shield, all 5 layers all have to unfold, and it all has to happen just right. And
Scary.
yep, it really is.
Scary stuff.
And if it doesn't work, you can't do anything about it.
That's right.
All right. Any other questions? So if you just happen to come in late here, we are not looking through our telescope tonight because we are completely overcast here at the Chabot Space and Science Center. In fact, when we came in, we actually had fog right down on the deck here, and we've got another cold front coming in tomorrow night here with more rain coming. We had a very interesting time last weekend. We had a very serious rainstorm here at Chabot, and we found out that the roof leaks even more than it did before. So
The domes or the skis?
Actually, the domes came out pretty well. There was a little bit of leakage in Rachel's dome, but other than that, we came out pretty well. But in the building itself, there were several big leaks, and so they are getting the roofers up here. If they haven't done it already, they will very shortly to get those leaks.
The good news is we collected a great deal of drinking water.
Yeah.
Yeah, and I think there was something like 4 inches in that one day recorded on the at the Chabot weather station. So just
right. Yeah, we actually
rain in 24-hour period.
Yeah, the average rainfall for Chabot has its own weather station, and the normal average rainfall for a season is somewhere between 18 and 20 inches for the entire season. So far in October alone, we've received nearly 7 inches. So we are well on the way to reaching our normal rainfall.
And most of that was in the last week or so.
Yeah, right. So, yeah, I think I recorded 4.65 inches on that one day last Sunday. So
wow.
Yeah, it was amazing. I mean, I left from the land of exceptional drought last Sunday, went to Seattle. It rained for 5 days. We were there. And then to come back to clear sunny skies, at least for a couple of days.
Yeah.
Amazing.
All right.
Well, if anybody else has questions, now's the time to ask them. And
before we go, guys, I have a couple of images I want to share.
Oh yeah, go.
We have a few questions going by here. Sabina asks, this is about the James Webb again. So what do they do if it doesn't work? It's pretty much a total loss if it doesn't.
Call Lloyd's of London.
Yeah, exactly.
Yeah.
I see a question on YouTube about the Viper mission.
Yep.
Viper mission is a rover that NASA is going to send to the moon. And was I correct that it was going to launch next spring?
Yeah, I think that's right.
Yeah.
We watched the whole presentation on it last week, and we're sitting here scratching our heads on when the launch is. I think he said next spring.
Okay. All right. Yeah. So Viper is a small rover that will land at the south pole of the moon, and is going to look for water, ice in some of those craters at the south pole that never get sunlight. So that's coming up here next year.
So a quick check. It looks like November of 2023. It says plan.
Oh,
for
okay.
Viper mission.
Shows you how well we paid attention last week, right?
Well,
So,
they're going to need some time to get ready for that, because as I understand the mission from the video that was presented, they're going to be driving that from Earth remotely, because
right.
now the moon is it's less than 2 seconds away. So they can actually drive that in literally real time.
That's right.
And they also made the point, though, they'd only be driving it when the area was fully illuminated. They would not be driving it into those perpetual shadowed areas.
Right. So they're going around the rim of the crater, but not down into the crater.
Hey, Rick, if you want to show those photos, you got to do it now.
Yeah. Okay, let me go here. So first one I want to show is, let me do that. I hope we're seeing this thing here. Let me go back to Facebook.
It was a 3-hour tour.
Okay. All right. We're going to make this real quick. So a couple of weeks ago, I had the occasion to go up to Inverness and at Point Reyes. And I was up there with a group of other photographers, and we went there to take a look at this ship, which is called the Point Reyes, and it's very accessible. You can see it. You can walk right up to it. So my goal that night was to do some star trail images. So I had my camera set up for that. And in the process, I've stopped my screen share. I got to capture another picture. In the process, a group of photographers went up to photograph the ship close. I didn't want to move my camera since it was connected to a tripod, and it was just too much trouble to move it. So I walked up between them with an iPhone, and this picture was taken with an iPhone 12 handheld, and the camera recorded about a 1.1 second exposure to capture what I call the ghost ship. And this is my Halloween contribution to the
It's
virtual
really great.
telescope program. So
it looks like a watercolor.
You get a kick out of that.
Yeah. It looks like a watercolor imagery.
Yeah, it does. It doesn't look real.
It really does. And when I first looked at it, somebody, and I shared it with a friend, someone said, you can almost see the brush strokes, And it really is incredible, especially to see the reflection of the ship, of our ghost ship, the Point Reyes, in the water. So
yeah.
Happy Halloween, everybody.
Well, thanks for showing those. Those are really excellent. We got a couple questions here. They're coming in fast and furious here.
Yeah, all of a sudden.
Is the moon rover, the Viper, going to be solar powered, or is it got a nuclear battery?
Solar powered.
Okay.
Yeah, it's got solar panels on the side of it, so it has to stand the sun. Although they were telling us that once the battery is fully charged, it can go quite a long time before it needs to recharge its batteries.
I think it was about 72 hours. They using solar panels because they're looking for, I think it's neutron radiation, and having a radioactive source would interfere with their instrumentation.
Right.
That's right.
Here's a good one. How far is Voyager 1 going to go? Well, nobody knows.
Yeah.
Until it hits something, I guess.
It might go. It's going to go. It's going to go forever.
until it collides with Nomad and returns.
That's right.
Yeah, it returns.
Yeah. This goes back to an earlier question about Star Trek versus Star Wars. We don't want to go there.
Yeah. Okay, other questions?
Well, Tim gave a partial answer to the previous question. He says Voyager 1 will pass within 1.6 light years from red dwarf star Gliese 445 in about 40,000 years.
I can't wait.
That's nothing. Yeah, mark it on the calendar. That's cool.
That is pretty cool.
Yeah.
What'll happen?
They'll send it back.
Yeah, the Galicians will send it back to us.
Yeah, with a bill.
A cleanup bill. Yeah. All right, folks. I think we've burned another hour of your time, and we had fun tonight. And
We are going to do this one more time next
one
week.
more time, one more Saturday time.
Right.
Yeah.
We'll
continue
we're going to come back and
do it again. We're not going away forever.
Yeah.
But we want to encourage people to get out from in front of their computer screens and come up the hill and visit us in person. We will be there during the opening, some of us anyway.
I think most of us will probably be there.
Yeah, we're all sorting out.
That was
what
one
our
of the
various
questions
roles
too.
are. I tend to hide in the telescope makers workshop, but I'll hopefully be out on the deck on the opening weekend with
We
a telescope.
did have
We'll
the
see.
big fundraising event last week, and it went very well. And the place looks beautiful, and there's a lot happening.
It went very well, except I lost my name badge.
Oh no!
no!
Oh no! There's
Just have
somebody
to put
else
in another
walking
100
around with
hours
a
to get
Gerald
one.
Yeah.
Egan
Yeah.
badge now.
By the way, I was not able to see all of the exhibit artifacts that were brought up by NASA, the NASA Ames folks, but there is one amazing spacesuit that I did happen to see from one of the Apollo lunar missions. And I think they were still trying to research who was actually wearing it, but it's a spacesuit that actually flew on an Apollo mission, and it's a sight to see. That's worth the price of admission all by itself, just to see those artifacts that NASA Ames has generously loaned to Chabot.
Yeah.
All right.
Okay.
Well, thanks,
All right.
guys. It was fun
Thank
tonight.
you.
And
Thank
We'll
you.
see you all next
Halloween.
time.
And keep your
All right.
fingers crossed for
Happy
clear skies.
Halloween.
Clear skies next week.
Watch out for that
Alrighty.
candy corn.
Yeah.